So now we will start with our final workshop. Today we will discuss about ReAct prompting, knowledge graph, and LLM blobs. First, let's recap what we have discussed in yesterday's session. On the yesterday's session, we discussed about a search engine, which is including keyword-based, vector-based, and then a search method that combine both methods is called hybrid search. And we will combine with re-ranking to scoring the information after searching and suggest to the RAG system. We also discuss about the advantage and disadvantage of each case when we use word-based, when we use vector-based, and the ideal use case that I think based on this information, this will help us when we deploy in our project. And also we discuss about how to implement RAG and how to fine-tuning the LLM model. The RAG, in short, that we will add relevant information from a specific domain to LLM prompt. Thanks to the search engine, we can find relevant information and we will add to the prompt. But let's say if our project is too specific, too special that LLM never seen before, then we can consider fine-tuning the model. The fine-tuning the model means that we will retrain the LLM with our private dataset. And in yesterday, we also discussed the benefit of RAG and disadvantage of RAG, as well as the advantage of fine-tuning and the disadvantage of fine-tuning. And we can come to the approach of hybrid approach that we will combine both RAG and fine-tuning. We can fine-tune our model on the dataset. We will select the data that's stable and less likely to be changed in the time. Then we can combine, then after we deploy the fine-tuning model, we can combine with RAG technique so that it can improve the model performance. So for today's session, there will be three content in today's selection. The first is about ReAct prompting. The second is knowledge graph, and the last will be LLM blobs. For the ReAct, let's remind about the LLM and RAG. The LLM, originally they train on public dataset. They have no information about the private dataset. But thanks to the RAG, we can convert LLM into a useful AI model for our private knowledge base. And the quality of RAG and LLM is strongly depend on the search engine. If we can search good content, then RAG is useful. But if we search bad content, then the entire system is bad. So let's say there are some problems with the LLM. As so far as we know, ChatGPT can generate the code. ChatGPT can recommend SQL code. And also, if you search for some information, ChatGPT can suggest something like, oh, let's do this. Let's read this paper written by Trong, for example. But what if the code suggested by LLM is incorrect? We're not sure. Maybe it's incorrect. Or when we do the RAG, we should find data, but that data only be done by execute an SQL code, which means that word-based and vector-based is useless right now. We should execute the SQL code. At that time, how can we do that? And if the LLM output suggests something, like I say, read this paper from Trong, how can we know that Trong really write this paper? Maybe LLM just hallucinate the answer. Or if before we come to the conclusion, we have to analyze or calculate things before going to conclusion. So this is a thing in real world when we work with the LLM. So how can we do? The easiest way to analyze is that let's analyze the human behavior. Then let's go and then we can find some solution. Let's go to this easy example. Someone say to you, California's population is 53 times larger than Alaska. So how can we know this? How can we verify this information is true or not? The easiest way is that let's break the task into sub-steps, and then we make a calculation and comparison. So let's break it. Someone said California population is 53 times of Alaska. So how can we verify that? Okay, for this step, let's compare the population of California and Alaska. Let's get both the population. So because if I suddenly say what is the population of California, of course no one knows. We have to check on the internet. So let's check on the internet. Okay, let's see. California's population is around 39.2 million, and Alaska is around 0.74 million. We check from the internet. Okay, good. Now they ask for the ratio. Then we should divide one by the other. But right now I have to use a calculator because I'm not good at calculation. So let's use calculator, and we find 39.2 divided by 0.74 is 53. Then we can have to check 53 sound like a reasonable result. We can continue. Then okay, looks like we have all the things we have. Then let's check. California has 53 times greater than Alaska. Then we can rewrite something and compose the final answer. And let's see. Okay, California population is actually 53 times larger than Alaska. Then we can verify this statement is correct. That is our human thinking. And keep going. We can, someone say that, let's find the capital of France and its population. So how can we do that? We're thinking in our head. To find the capital of France, we need to recall the geographical fact. So we remind when we study in Chodenhakkyo, we know that Paris is the capital of France. That's our thinking. It's in our action. Then we start thinking. Now we know Paris is the capital of France. What should we do next? Well, just find the population of Paris. But the population is a thing that will change over time, so it's required up-to-date information. We can make some actions, such as go to the Google and search for current population of Paris. Then, okay, now we have the current population of Paris. Let's ask ChatGPT to generate the answer and answer the question. So example 1, example 2 is easy case. But in practice, things is not easy like that. Someone say it is kind of more difficult. Write a SQL code to show the revenue of the first 3 months. This is a thing that I'm doing in the Canvas SQL right now. So if I apply ReAct to this problem, how can I do? First, they say that show revenue of the first 3 months. So in my thinking, I have to determine the suitable database object are involved because there are many databases. And after searching, I think, oh, looks like sales database and the column sales days and amount may be suitable. So let's select that. And the question they ask is the first 3 months. So let's filter for the first 3 months. But the year isn't specified. So just use the month function to extract the month number. Then we can thinking about, oh, maybe we will sum up the revenue for this month. We use a sum function. We will group the result by month for clarify, and we can use group by. And we're thinking that we should show the result in the chronological order. Then we will add an order. Now we have enough function. Then we will ask LLM, let's generate the SQL code. Then LLM will write the SQL code. But here's come the problem. Is this code correct? We don't know. We can't tell. So by action, we will execute. We will connect to the third-party platform and execute the code in SQL. And somehow we found there's an error. There is error happen. So in my thinking, I will think, okay, let's solve this error. We put the code and also the error to the ChatGPT prompt and say, this code has an error. Fix it. Then the action, ChatGPT will rewrite the SQL code and run it, and luckily it's success. Then now it's run to show the output. And as you know that in SQL, the output usually is a table. But this is the finance problem. If we show the table, this is not a good option. Let's display in graph instead. Then by action, I will call a Python function to display a graph, and this is the output that we have. So actually, this is a real product, not my imagination. This is a real product from SAP Joule. SAP Joule already implemented function. Someone asked about what is the hiring versus attrition trend for this job role in the past 12 months. And on the back, SAP Joule, they also execute and find the table, connect the table, write the SQL, and display the table. So this is the real product. And finally, they show some conclusion. The SAP Joule also utilize a LLM model. So all of the way we're thinking, the way we act, and also the way we revise the code, all three components we call, all three components form a prompt technique called ReAct. ReAct is a short form of reasoning and acting. It's you can imagine when you work in with ReAct, you are detective. Maybe you know the character detective Gadget. You receive a problem. Someone send you a problem, but instead of just answer the problem immediately, you would better analyze a current situation, analyze the problem, then propose how to solve by proposing step by step by step. And on each step, we will take a suitable action on each step. And then after take the action, you check the result. Is the action outcome good or not? So for easy to observe, you can see this example. Someone asks for something, and you, in your head, you thought that you need to search for Apple Remote and find the program it was originally designed to interact with. Then in action, you connect to a search function. You search for Apple Remote. Then after you find information, you put it back to the LLM model. And you observe this information. Observe number one, Apple Remote is the remote control, blah, blah, blah. Okay, that is the first outcome after your first action. Then you say, and when you read the observation number one, you find out that you need to search for the front row next and find what other device can control it. Then you connect to another search engine and find for information of the front row. And somehow you find that you cannot find the term front row in your data. The thing you can find is that front row seat to earth, front row motorsport, front row software is not related anything to the Apple. So in your thought, you're saying that front row we cannot be found. We need to search for front row software, which is front row Apple, for example. You have the action, you have to observe, you have another thought, and you have another action, and you think that in the final thought, you find the answer. The front row software is controlled by Apple Remote. Then the final answer will be keyboard function key. Okay, thankfully you reach to the good conclusion. Then you stop. So ReAct, technically, you break the problem into step by step. On each step, you take suitable action. You connect maybe to the third-party software. You maybe connect to a code learning program. You collect the output. You put to the prompt. You verify the information, and you come to the next step. So the process is keep coming and keep coming until you reach the final answer. So how can we apply ReAct in practice? So let's say someone gives the input. Joe Biden was born in Scranton, Pennsylvania. So how can we know that? We can ask ChatGPT to make a step for you that Joe Biden was born in. In this case, you have to connect to a search engine to find the original birthplace of Joe Biden and add in here. And you check keep the QA in which state in Granton, and you check on your data set and you put into the output prompt. And then you can ask ChatGPT to verify the answer. It's similar. Someone asks this statement, you will start breaking into some sub-step here, and then you can compute the final answer. And in practice, someone maybe ask you for this. They ask you for get me a 16-pack of Apple cinnamon freeze-dried banana chips, and the price lower than $50. So how can we do that? In this instruction, you can see that they say 16-pack of Apple cinnamon freeze and dried banana chips, and the price must be lower than $50. So they have two phases. First, let's search for the third phase: 16-pack apple cinnamon freeze dried banana chips. Then after you searching, you find this information in your database. This is the information that you found in the database. It includes fruit crisps and dry fruit snack and fruit snack. You find something, banana script something. Maybe this one is relevant. Then you start thinking. So far right now, after retrieval, you have 3 outcomes. So in your action, you have to analyze 3 outcomes. The first outcome is about strawberry banana, not apple cinnamon, so you can skip that. The second is the fruit snack, not freeze-dried banana chips, skip that. The third is banana script, not apple cinnamon. Okay, maybe we can consider about that. So let's check this option. And the observation say, okay, let's go to the next action. So the action right now, we will select this one. And after we decide to go with this option, we will check for the price. And when we check, we see that the price is around $12.99. And the requirements say lower than 50. Okay, so right now we can think, okay, looks like this one is a good option. Then we will decide that, okay, this is our final answer. We will print this one to the customer. For easy to explain, if you use GPT-4, the GPT-4 technically they also follow the ReAct option. Maybe you already see that when you work with the GPT-4. Someone said, GPT, let's write a file in this folder called hello user2.txt with no content. And if you see the word finished working, which means that ChatGPT start doing their action they are making on the back system. Then after they finish making on the back system, they display the code, the Python code for you to see here. And after that, they generate the final answer. Oh, okay, the file already created. You can download if you need. Or someone can say, are you allowed to save database between different conversations with the same users? And after answering the question, let's list all the files in this folder. Then ChatGPT start thinking. They said, oh, okay, I am AI. I'm just the AI. I don't have the ability to save the data. And also they ask for list all the files in MNT data folder. Then at this step, ChatGPT start taking action. If you see the word finished working, that they start taking action by writing a Python code right here, and they execute this Python code on the back. And after finish execution, they will see this result. There are 2 files on the folder on the directory, and they write an output. The file present in this folder are 2 files. Or the first or the third one may be a little bit complex. Is that let's do not run a loop, run the function individually, then report back and repeat. Then the ChatGPT start write the working and write some information, check some information, then verify the information by rerun the code again and read the output, check some memory function, and say, okay, the file already saved in our office. Then check another function and see, okay, this is after running the file, this is the memory that consumption. So as you say, as you can think that the ReAct, technically that is the variant of RAG. It's no different. But the one slightly different is that instead of RAG, we use one time using search engine and put in here. In ReAct, we will break the query into multiple sub-problem. And each sub-problem, you ask for RAG to collect the data. The collect data right now, on yesterday, I say that we will use search engine. But right now, besides search engine, we can run the code and put the output of our code to the RAG. Or we will execute SQL and put the output SQL to the RAG. That's also possible. Or we can assign with a third-party platform for Google search and collect the information on Google search to the RAG. That's possible. So that is the thing of RAG. They are not just focused on search engine, but they then connect to any third party as the supplementary to the RAG. So there are some challenge of React. If you think that why this method is so complex, I not understand at all. Yeah, you're right. That is one disadvantage of React, the complexity.
Before we move into the detail,
Yeah,
so I sort of I see the benefit of React and how it works, but search engine is sort of a sub-function of RAG, you can say.
yeah.
It is similar. React is also subset function of RAG or
Supportive platform.
okay.
Yeah.
So search engine and the React is sort of a similar level
Not quite
or
similar. React is kind of a platform, not a platform, a protocol.
protocol.
Yeah, such as in yesterday, when someone sent you the question, you will use search engine
Mhm.
and find information and put to the prompt. Or in my way, sometimes you have to write a chain of prompt. You chain of prompt. You detect the language. You rewrite the question. Yeah, something. And React is a way you analyze the question. When you receive the question, instead of going to search engine, you will take deep analyze. Someone said, Alaska is 53 times. California is 53 times larger than Alaska. Instead of bringing all big of information and to the search engine, you will start break into some task. First, find the population of California
Mhm.
and ask for search engine. Then find the population of Alaska, ask for a search engine again. Then calculate the ratio. In this step, you have to ask for a calculator. You cannot ask for search engine anymore. They made some calculation. So, and then you put the information back to the prompt and generate the answer. So kind of supplementary of things.
그 문학생 리액트 좀 질문 있었어요. 아직까지는 괜찮다고. 왜냐면 제가 물어보는 거는 제가 뭔지 잘 몰랐어요. 한국말로 좀 이야기해 주면은 좀 도움이 될 것 같아서. 아, 그러니까 실제적으로 코드를 실행을 백 쪽에서 그 AI 쪽에서 한다는 거 조금 제가 잘못 그 검증을 거친다는 건가요? 그러니까 조금 전에 제가 그 서치 엔진, 검색 엔진, 뭐 벡터 DB, LLM하고 결합을 해가지고. 네, 네. 그래서 이제 리액트가 이제 리전 X 전에 그렇게 알고 있거든요. 그래서 우리가 리저닝을 한다고 했을 때 이게 좀 구체적으로 어떤 건지 혹시 이해하고 있는 게 있으면 제가 답을 알고 있어서 물어보는 게 아니라 같이 좀
RAG하고 서치 엔진은 좀 그런 관계가 어디 좀 쉽게 저는 이해되는데 이것도 분명히 RAG를 하는 어떤 뭐 툴 뭐 그런 거일 것 같긴 한데 잘 어떻게 되는지는 잘 모르겠네요.
저는 들을 때는 그걸 생각했다가 나중에 집에 가서 생각해 보면 헷갈리더라고요. 지금 프롬프팅이나 이런 기술들이 엄청나게 많은데 또 리액티브는 뭐 매번 나오는 이야기라서
혹시 리액트하고 RAG 사이는 어떤 관계예요? 이해하고 있는 분이 있어요? 방금 설명을 했는데 저는 하여튼 뭐 리액트를 수행하는 어떤 그 툴 중에 하나다.
계속 지금 계속
Okay.
Okay, so
So React is reasoning and
action.
action.
Yeah. So because we have to do some reasoning and we have to do some action, and sometimes we break the problem to many steps, it will lead to some challenge. The first challenge that obvious, that is the complexity. You can see that if the problem is more complex, we have to manage the reasoning and action step. Maybe we have to break the problem into many steps, and each step is maybe required many actions to finish that step. So that is one challenge of React, that the complexity. And one drawback is that the process may become too detailed, too lengthy, and this can lead to inefficient or overwhelming the model, and maybe too many intermediate steps. Because in practice, given the problem, you don't know how many steps you have to take. And especially in our project, if they need a phone call and they need a low latency, apply React sometimes is quite dangerous. You can imagine you put the React and they say, oh, we need 10 steps to solve this problem. Each step we have to wait for around 1 or 2 seconds. Then we have to wait for 20 seconds in total. So that is one challenge of React. The next challenge is that a error propagation, maybe I should put in this mode. Okay. The error propagation is that because you break the problem into sub-steps, but what happened, you get wrong answer at the first step, it will make the entire step is wrong too, because the second step related to the result of the first step, the third step related to the result of the second step. So if the earliest results is already wrong, it makes the entire process wrong. It's already happened in ChatGPT 4. When I use ChatGPT, the ChatGPT write a code, then suddenly they say, I'm sorry, the code is wrong, let's run again. Then they say it again, oh, I'm sorry, the code is wrong, let's run again. And they make the entire loop is never stop. And the third challenge is that the model limitation. So far, I am discussed about ChatGPT model, but in practice, we can use many models, not just ChatGPT. So the model's underlying knowledge and capabilities might limit the effectiveness of React prompting. For example, our task required code generation, but our new LLM never learned code generation before, so obviously they cannot finish the task. And the last one, which is our big challenge in our project, is the processing time. That the iterative nature of React prompting can increase the processing time required to reach a solution, especially if we need something related to code, such as in our Canvas SQL. I apply React to find the table, to find the column, connect table and column, and generate the SQL. But sometimes the SQL code is wrong, so I have to ask for the React to do it again. But the code is still wrong, and I ask the React to do it again, but the code is still wrong. And after I find out, the problem is that our database is problem, not the code is problem. Yeah, that's also the challenge, processing time.
So RAG itself has a sort of a latency disadvantages, right?
Yeah,
And React seems to have a bit more sort of a disadvantages about the latency or processing
yeah.
time risk
Re-
or issue.
React, technically they already have the RAG inside, because like I say, when you work on the second step, you have to know the information on the first step. The way you know is the RAG. So technically they already have,
Okay.
but they need some verify something, so it takes
Okay.
some time.
평소에
Mm.
리전 액트 에자이 언더스탠딩 이제 more predictable than RAG. Such like when we query about please recommend best notebook,
Mhm.
and then he GPT has LM only have in their database, but their database is not renewed, so they LLM needs to search in search engine, and
Yeah,
LLM
yeah.
search laptop in Google or Naver, and then suggested with the response. It is a React
Kind of.
kind of
Yeah, because React it just simply you break the problem into sub-step, and each sub-step you take action. Simple explanation is that.
리액트라는 게
Yeah.
저희가 RAG 하면은 상담 RAG 한다 했을 때 상담 데이터에 있는 그 지식 DB 갖고만 하잖아요. 거기서 RAG를 계속 하는데 이제 그거 말고도 정말 실시간성으로 뭐 어떤 정보를 갖고 와야 될 수 있고 검색 엔진에서 아니면은 예약하거나 제가 예제를 조금 물어봤어요 LLM한테. 근데 뭐 LLM이 뭐 최신 뉴스를 요약해야 한다고 할 때 자체적으로 최신 뉴스를 알지 못할 수 있어서 검색 엔진이랑 통합이 돼 있으면은 CMS를 검색해 올 수 있는 것처럼 좀 외부 플러그인들이랑 외부 뭐 사이트 서비스들이랑 통합을 해서 실제로 뭐 검색도 해오고 저희가 제미나이 같은 거 사용하면은 실제로 막 웹사이트 주소를 가져다 주기도 하는데 아마 뭐 구글 엔진이랑 검색을 해서 탑에 있는 뭐 3개의 주소를 갖고 오는 그러니까 그게 이제 기존의 지식 DB에 들어있던 게 아니라 방금 검색을 해서 갖고 올 수 있는 그리고 예전에 구글에서 파트너가 왔을 때도 그런 얘기를 했었거든요. 기억하시면 혹시 저희가
저는 뭐
썼던 거
리저닝 액트 서비스를 제공한다 그래서 제공하는 모양이다.
네.
리저닝이라는 말 자체가 단어의 뜻이 리저닝이라는 말 많이 들어봤는데 그래서 과연
리즈닝 앤 액트라고 딱 이렇게
리저닝이라고 하면 일반적으로 이게 우리가 이유 원인을 이런 뜻으로
그렇죠. 여기서도 그런 의미로 사용하는 거.
그럼 여기서는 약간 소스를 뒤져본다?
그
여러 가지
결과를 뒷받침해줄 이유들을 가져오는 거죠.
그러니까 뭐 구글 검색이나 뭐 지식 DB, RH 검색이나 이것들을 해서 최종적으로 뭐
어느 소스에서 가져올지도 본인이 이제 결정을 해야 되는 그런 스텝들이
액트라는 거는 사실 리저닝을 하기 위해서 액션을 취한다 이렇게 그럼 되겠는 거죠.
저는 방금 이제 그 리저닝하고 액션이라는 말을 들으면서 제가 좀 생각이 든 게 제가 지금까지 이해했던 이 소위 LLM 모델은 리저닝을 하는 이런 류의 논리 추론을 하는 것보다는 확률적으로 기존에 있던 데이터베이스에서 나오는 걸로 했는데
그 영역 자체를 그 기존에 자신이 학습한 모델이 아니라 외부까지 확장을 해가지고 랭귀지 영역까지 포함을 한다는 게 리액트의 핵심적인.
그러네요. 세션 할 때도 그런 게 필요하겠네, 그죠? 뭔가 우리 내부의 정보 플러스 뭐 이건 우리 거 아니니까 뭐 어디 딴 데 알아봐라 뭐 이럴 수도 있을 것 같고.
네.
근데 알아보려면 뭐 뭔가 정보를 찾아서 이렇게 제공해 줘야 될 테니까.
저희가 LLM 사용할 때 뭐 주소 같은 거를 기입을 하고서 하면은 얘가 이제 가끔 인식을 해서 주소에 대해서 검색을 하면서 갖고 오고 그럼 이제 검색 중이다라고 하고 그것도 이제 리액트에 가지고 주소가 들어왔으니까 이 주소에서 나한테 정보를 알려달라는 거 본인이 이제 요청해서
오케이.
Okay. Okay. So let's analyze again the disadvantage because we understand correctly about LLM. LLM technically that is a word guessing game, just guessing the next word. So therefore there are one limitation, that is the model can make error propagation. We ask the model for listing the step, but because this is a word guessing game, sometimes the step listing is wrong at the beginning, or the step finding is already wrong at the beginning. So that is also one error. So if we apply for our project the suggestion, we can adjust the input. Like we can say to ChatGPT, let's analyze this problem in 3 steps. So we will limit the step by ourselves.
Okay.
So just to solve this problem, we need to step 1, step 2, step 3. In step 1, we will connect. In order to solve the first step 1, we can connect to a search engine. We can connect to a programming language and execution some function and take the output to the step 1 and analyze and verify the output. Then go to step 2 and go to step 3 and jump to a suggestion. So that's one way. But if you think anything so difficult, especially for the suggestion, I think it is better to go to the knowledge graph. Maybe easier to do than the ReAct. The knowledge graph, technically this is a structure presenting relation between entities. The entities right here can be the foreign keys between tables. The tables will be the entities, and the connection between nodes are the foreign keys, or maybe a section of a chapter. The entity will be section and chapter, and the connect will be this section belong to this chapter. So we have a connection between the section and the chapter. Or we have the entity is the person, job titles, nationality, but this person have a specific job and specific nationality. We can also have a connection. For detail, you can look at this graph. For example, we have the information of Elon Musk, the Boring Company, University of Pennsylvania. Then we will establish a connection such as Elon Musk is a resident of University of Pennsylvania. Work location is in University of Pennsylvania. Or the Boring Company owned by Elon Musk, or the Elon Musk owned by Tesla company. So that is the way we make a graph. Or in the text to SQL we are drawing right now. In this problem, I have to work with table and foreign keys. So I build a graph to make a connection between two tables. In SQL concept, two tables can be connected via foreign keys. So you can see that the table on the top, domain author and domain, you can see that domain author point to the domain, mean that in the domain author, they have the foreign key that connect to the domain. Yeah. So now it's a graph. We have the graph. Let's go to the detail. The nodes, like I said, they present entities, which can be a product node. And the product node can include some attributes such as specification, availability, and compatibilities. And between nodes are connected by edge. So the edge will present relation between entities, such as relationships, such as the dependencies, compatibility, or substitution option. So specifically, also finally, what should they do? What can they do? Let's say some application say that. Can product X be integrated with product Y? We can do like this. We find they have two entities, product X and product Y. And we check product X in our graph and product Y in our graph, and we can identify the node position. Then we will find a shortest path or most relevant connection between this product, and we make a connection. This product, one product go to another product, they must pass through the edge. And the edge sometimes information about the relationship between two nodes. So by find the shortest path, connect with the edge, we can find how product X be integrated with product Y.
It's similar with the vector DB.
Yeah, it's quite different is that sometimes they have some hidden node in between. If we apply to vector DB, they just find information of product X and information of product Y. But the hidden node in between, vector DB cannot find because we never ask. So, for example, user requests product A, but somehow out of stock. So now is the time for suggestion. So now product Y A is out of stock. We cannot say, oh, sorry, we don't have product A. In business perspective, that is not a good approach to deny the customer. We can use the knowledge graph to suggest a product B as an alternative if it has some similar specification to product Y, to product A. Someone can say, can you have a pen? I'm sorry, I don't have, but we have a pencil. It's really good. Let's use this. So it's in business concept, this is good. So in our work and suggestion, we also follow this way. Mention in the graph, and someone makes some suggestion, but for some reason we cannot do that suggestion. We can have some alternative solution to replace, thanks to the knowledge graph. So in practice, yesterday we are talking about search engine. In practice, many people also implement the knowledge graph as part of a search engine. For example, some user asks a question, and you can see that this data, yesterday we make some keyword search and vector search on our database. But we can also have a third option is that we can make a graph search. From the question, we will identify the entities, we check on the knowledge graph, and we can make some graph calculation, graph connection between entities as a node. Then we can combine the source, and we will ask LLM for generating the answer. Let's go to the practical example.
Sorry,
Yep.
can I go to that?
Sure, no problem. So we talk about the knowledge graph as part of the search engine, and let's see in practice how this works. In practice, someone can ask that, who is Amelia Earhart? Then that is a question. So the LLM will extract the entity. The entity is the Amelia Earhart. Then this identity is fed to the knowledge graph, is the middle. And from the middle, you can see that there are 1, 2, 3, 4, 5 neighborhood nodes. And then the relevant nodes with the neighborhood will be extract and flattened. So you can see that Amelia Earhart is the middle, and you can imagine 1, 2, 3, 4, 5 nodes outside. They are maybe nationality, born in Atchison, Kansas, raised in Iowa, or work at Purdue. So from that node, they can connect to their neighborhood and form the entire information. And these results will be passed to LLM. This will be a part of the RAG and passed to the LLM. So this is the big example. So you can check the Elizabeth. Someone can say when the Queen Elizabeth dead, then we can check the entity Elizabeth, and the age is dead. So Elizabeth dead, Elizabeth dead in 1603. Or someone can say who is Elizabeth, and then we can have many information. Then we can concatenate all of the neighborhood age and from the final answer. So that's one way to the knowledge graph work in practice. But in practice, the thing may be more complicated than that. For example, someone can ask, where did Canadian citizens win the Turing Award graduate? So they have some entities such as Canadian citizen and Turing Award. So we check on the knowledge graph, we found, okay, this is the entities for Canada. This is the entity for Turing Award. In the Turing Award,
what's the question?
where did Canadian citizen win with Turing Award graduate?
Win with.
With.
Yeah. Okay.
I'm sorry, my pronunciation. So we have two entities. Number one is Turing Award. Number two is Canada. And from the Turing Award, you know that in the world there are many people wins the Turing Award, such as Pearl, Geoffrey Hinton, or Yoshua Bengio. And there are also many persons was born in Canada, such as Hinton, Yoshua Bengio, and Bieber or Justin Trudeau. So you can see that these two nodes are most related. They are Canada, and they both win the Turing Award. In Hinton, work at the Edinburgh University. Yoshua Bengio work in Cambridge, and Hinton work in Cambridge, and Yoshua Bengio work in Macquarie University. So we can combine this node and all of these nodes and produce the final answer. We can say that ChatGPT, they found that there are two Canadian citizens win the Turing Award, that is Hinton and Bengio. Hinton right now work in Edinburgh and Cambridge, and Bengio work in Macquarie University. So, graduate. Graduate is better than work. So that is a way to do.
You missed the win.
Yeah, the Canadian, the Turing Award win. The age represent the win.
In the question.
With.
Before you need to win.
Yeah, I'm sorry, my bad pronunciation. So it's
not first pronunciation. You missed the word win.
With actually the original is a with. Canadian citizen with Turing Award graduate.
Graduate.
Yeah.
Okay, sorry. Okay.
Graduate.
The question is okay. Where did he graduated?
Yeah, exactly.
Okay.
Sorry, my bad pronunciation.
No.
Okay, so in my in my Canvas SQL, someone can say like this. In knowledge graph, we will search by graph traversal. Someone say, find scientific conferences present papers about RAG. So we need to find scientific conference that present papers about RAG. So on the right side, this is our graph. So this is the potential scenario, because I'm not finished this project yet. So this is just potential scenario that I'm thinking. Because we need to identify the scientific conference. So we will use the conference table to identify the conference. And we also mentioned about RAG. So we can use the publication keyword table to identify the keyword RAG, which means they are here and here. Yeah, see? So from here to here, they don't have direct connection. See, publication keyword and conference, they don't have direct connection. If we go to publication keyword to conference, you have to pass through publication. Then from publication to the conference. This connection can happen via the foreign keys. So how can we do that? We can find the shortest path to connect two tables. So after find the shortest path, we can find publication keyword to publication and to the conference. And then we will ask LLM for writing an SQL code and generate the answer. So at this step, it's kind of a small version of ReAct. We're thinking, we have some action, and we will observe. It's just the simple. It's very, very simple.
Yeah. For enterprise business like Samsung,
Yeah.
it'll be huge data set.
Yep.
So in order to utilize this knowledge graph, do we need to build these tables by ourselves, or we?
I will explain on the LLM OBS, LLM blobs. I will explain how to do that.
Okay. You'll come. Okay.
Luckily, this is a 21st century, so we don't need to
that's,
do everything by hand.
I felt that's too much.
Yeah. So the problem say that in here I say that use this table and use that table, but in practice, how can we find those nodes? So now it's time to use our search engine. You remember 2 days ago I said that focus on the search engine. So this is the reason. Focus on the search engine on entities. So let's get back to our question. Find scientific conference, present papers about RAG. First, we apply name entity recognition, and then we can find the node are scientific conference and papers and RAG. Then we will combine with the hybrid search and we'll find a list of candidate nodes, which means that one node we have many attributes. The node name, the node summarization, the node keywords, the node attributes, the node function, something. So from these functions, we can apply hybrid search to find the candidate table, candidate node. Then here comes, now we have a list of candidate nodes. The second question is that how to link those nodes together. And we have to notice that some node may not relate to our problem, because that's why I call this is just candidate. So one way to do that, we can apply graph computer science. When you study computer science, you can apply some technique about graphs, such as minimum spanning tree, depth first travel, or breadth first search, to find the connection between the nodes. And also you can find the node that's in single or the node in the cycle, that we can follow that. So like, 네, 안녕하세요. So to link those nodes, there are many techniques, computer science techniques, such as finding the minimum spanning tree, depth first traversal, and breadth first search. And talk about link those nodes. I also have some application that when I work with Kenya's SQL, I have to convert the code from SQLite to Postgre. And technically, when we work with SQL, one table have the foreign key to another table, but we have to arrange the table in the order. Like if table A has the foreign key to the table B must be created first, then go to the table A. But in the SQLite, the table just placed randomly. They don't have the order. So when I convert to the Postgre, it's made an error. Execution, they say, oh, this table not created first. So at that time, I apply the knowledge graph to link those tables and apply the topological sorting on the graph. So they sort to complete the order. So then I start executing. So graph B first, then graph C, then graph F, then graph A, then the problem solved. So that is one application. So yesterday, like I said, when I work with the keyword base, I also mentioned that we should generate more keywords so that we can find the keyword easily. So in the knowledge graph, that kind of philosophy also follow. That to find the nodes, we should maybe add more relevant attribute to the nodes, then it can helpful on finding that node. such as the entity name, entity description, the characteristic of entity, and these kind of attributes we will call as metadata. Let's say, for example, someone has the product review. Someone put the product review. It's quite really long, right? So we can apply a name entity or other function to add the metadata information, such as we can apply sentiment analyze and say, oh, this sentiment is positive. And we can add another function to define the product, because this review mentioned a product name as cellulose nylon Japanese and bath wash clothes. So if someone search information about the bath wash clothes or towel, we can have the chance to find this node and take the information out. Or the issues type, do they have any issues with this? Oh, the price is no, the answer is no. And the pricing and shipping issues and other metadata we need to add this information. Also, this also happened on the bottom. You can add some metadata to this. In practice, there are many ways to add metadata, such as we can have form submission. We will classify the suitable category. The category can be used as a part of metadata. For example, in our project, we should suggest something. So at the text preprocessing, we should add metadata such as the category of the text, so that if we have some suggestion, we can find suitable category and we collect good information of that category. So by adding the metadata, it will be helpful when we find in the node. And in practice, the metadata is quite long. So this is the example in my work, text to SQL, that you can see that I have vector and keyword column and vector and keyword table. That is the metadata respect for keyword level and table level. So let's consider the table level. In the table level, I have database ID because I have many databases, and table IDs and the keywords. The keyword right here can be a summarization of that table, the function of that table, the attribute of that table, and the purpose of that table. And then I can also add some short keyword to describe that table, so it's form really long. And because in order to find the table, we can apply the hybrid search, so I also add the embedding model. So each keyword, we also have the vector representation. So then we can apply the search engine. To describe the metadata in practice is quite really long. For example, in our project, the feedback from customer is a text right here. In practice, the text might be really long, so we can chunk and break the long text into the subtext. And this part, you can imagine that is a one subtext, so one subtext in the long big text. So in this subtext, we have some metadata such as the class name and the class value, or the file this graph belongs to, the date we create this graph, or maybe some hashing code or other type, the attribution. So the metadata in practice may be very huge and need carefully management. So that is the node description. Now we have to identify the edge. The identifier of the edge is to identify the relationship between one node to another. So one way to identify, we have a method called ontology. The ontology will define the type of entities and the relationship that can exist within a specific domain. For example, in SQL, we have 3 tables right here, and each table has their specific columns. Then we can develop ontology like this. We define keys entities such as customer, order, and product, and then we will establish a relationship such as place, such as the customer have some order. The customer is related to the order because the customer want to buy things. Or the relationship is contained, such as the order contain the product. Or the purchase by is the connection between order and column. We can say that this order is purchased by this customer. So that is the ontology development. And the attributes, we can identify attribute relevant to each entity, such as customer ID, name for customer, order days, and product ID. So here are the example of entity definition and relationship. The entity definition, we can identify the customer is an individual who make purchase. So given a text, if we apply name entity recognition and we find, this is the individual, then it will likely, we will go with customer table. Same logic will apply to order, is the transaction, products is an item available. And then we start having relationships such as the place, such as where the customer placed an order. Because like I said, customer and order have a relationship, and that relationship is the place. Or the contain is the relationship of order and product. We can say that this order contain this product. A pen contain maybe ink. Yeah, so that's way to explain the link relationship. Or the relationship may be purchased by. The purchased by relationship means that this order is purchased by this customer. So when we have the node and we have the edge and we flatten the result, we can write on ChatGPT that this person, this pen is purchased by Trump, and we put that to RAG, and ChatGPT will summarize and rewrite everything to a complete sentence to us. And this is the code knowledge graph for COVID-19. So in COVID-19, you can see that we have many information related to COVID-19, such as tweet on Twitter, Google Spreadsheet, or random notes, lots of information. So we will link anything to a graph, such as the COVID-19 random notes. Maybe this information is about SARS-CoV-2, or COVID-19 tweet is about the COVID-19 information. And even inside the entity description on this graph, they have like COVID-19 or New York as a node. Then we can have an edge is like New York is the state of the United States, and some properties to connect. So by describing a knowledge graph in practice is quite complicated, but quite useful.
Have you know Palantir?
Who's?
Palantir.
Palantir? No, I never
You
heard.
don't know. Okay. There's a AI model or solution called Palantir.
No, I
They
never heard.
I have studied a bit, and Palantir is one of the most I can say super AI solution at the moment in
Wow.
the industry,
Mm.
especially for the defense industry, like army.
Yeah, I never heard about that. So
It's used in the Ukrainian war at the moment. Anyway, so in Palantir they are stress the ontology model. That's a core key model of the Palantir. They have three ontology elements like entity, relationship, and event.
Okay.
The entity is the same with this, and then relationship in between entities, and the event is like I can say it's an activity. We purchase, we sell.
Okay.
Those things. And they build a huge ontology model for the U.S. Army. So see, this ontology is a common for the AI. I haven't heard about this before Palantir. I thought Palantir ontologies are unique for the Palantir, but it's not. It's common.
Yeah, it's very common, especially building knowledge graph, because you
Okay.
implement how to relationship between graph. So quite common information.
오케이. 제가 팔란티어를 조금 공부를 한 적이 있는데 이 온톨로지가 엄청 중요하다고 해서 이거 좀 들여다봤더니 뭐 이 온톨로지 가지고 팔란티어가 모든 걸 다 해결한다고
비슷하죠.
하더라고요.
디포커스에도 그쪽에 일을 볼런티어 쪽그 일을 나간 사람들이 있는데 관련해서 그뭐 저다 보면 그림이 비슷해요.
거의 똑같네요. 네.
그래서 뭐 팔란티어가 최초의 주장 온톨로지랑 최초 주장은 아니고
이 커먼 그러니까 보통 기술인가 보죠 이런 쪽
네.
이런 쪽에.
네.
오케이.
Okay, so this is the practical example on Kenya's SQL that I'm developing so far. It's not finished yet, but it's just a proposal that when users send a query, I will apply name entity recognition to understand the purpose of this query, the keyword that can contain in this query, and the table name if exists. The keyword may be the noun of this query, verb in this query, or location in this query. So this information helps us to find a table. So then we will find table from these entities. We can find table by the purpose, because sometimes the user will not mention the table directly. Maybe they just mention the purpose. They want to do something. So in the table, we can find table by related purpose, or they just say some short keyword like RAG. Then we can find by keyword. Or in the good case, if they mention the table name directly, oh, what's so good, we can find by table. So after find the table, we have the list of candidate table, because we're not sure all tables are correct, are correct selection. So we go to one step called table selection. We can ask LLM for select correct table, like I did on Kenya's GPT. Just make a loop and shuffling. Then we can combine with table description, and we can explain why, and we can ask ChatGPT to explain why select that table. This technique is called chain of thought. Then we can follow strategy to find table. And then when we have the table, when we have the columns, then we can ask SQL to generate SQL code based on the table description, based on user query, and we can run the code. But after run the code, we have to correct any error. Sometimes the code gets some error, then we have to call ChatGPT again to correct. So this ideology is quite similar to ReAct, but just a slightly simple version. So in this afternoon, I will explain about the LLM blobs and finish the workshop.
Excellent. Thank you.
Thank you.
3 minutes. Okay.
Yeah.
Perfect.